Hello everyone, welcome back to From X to Integration, your complete math journey from start to finish. So if you watched our functions video, you already know what a function is and what a domain means, and also how to identify a function in 3 different ways. If you haven't watched that video yet, I'll link it above, so go watch it because today's video is gonna build on it. Okay, so in the previous video, we said that a domain is all the valid inputs, and today we're going to answer a very important question, which is what makes an input invalid? Because not every number is actually allowed into every function. Some inputs actually break the function. And when that happens, we need a way to describe exactly which inputs are allowed and which aren't allowed. And this tool that we used is called interval notation. So before we even get into interval notation, we need to understand it. And in order to be able to fully properly understand interval notations, we're going to talk about inequalities first and try to understand that. So today's video, we're covering 3 important things: interval notation, inequalities, and domain restrictions. So yeah, let's get into it. Okay, let's start with interval notation. Interval notation is just a way of writing a set of numbers on a number line. That's it. I know sometimes it can look a bit fancy, but really it's just a shorthand for describing which numbers are included. So the most important thing to remember for interval notation is that it always goes from smallest to biggest. That is left to right. Smaller number first, larger number second. Always. Okay, let's start with the simplest interval, all real numbers. That is every number from negative infinity to positive infinity. How do we write this in interval notation? We write it like this: open parenthesis, negative infinity, comma, positive infinity, close parenthesis. This means every single number on the number line is included. Now let's talk about the symbols that we use for interval notations. We use either brackets or parentheses, and they mean completely different things. So let's start with parentheses. Parentheses looks like this, and it means that that number is not included. It's the same thing as when you have an open circle on a number line. It also means not included. So parentheses for interval notation means not included, and open circle on the number line also means not included. So now let's look at this number line. How do we convert this to interval notation? So it's pointing towards the right, which means it's every number that's greater than 3, right? What would this look like in interval notation? Every number greater than 3, but 3 is not included. So remember, we start with the smallest number, which is 3, and we go to the biggest number, which is infinity. Infinity is never included, so it's always going to have a parenthesis. And since it's an open circle, 3 is also not included, so it's going to have a parenthesis. Now let's talk about brackets. Brackets look like this, and it means included. It's the same thing as when you have a closed circle on your number line, because that also means included. So then, how would we convert this number line to interval notation? Once more, the arrow is pointing in the right, which means every number greater than 3. We start with the smallest number, which is 3, and the biggest number, which is infinity. Since infinity is not a real number, it always has parentheses. Now there's an open circle on 3, which means it is included. So instead of a parenthesis, we're going to use brackets. So this is what this will look like in interval notation. So this is a very important rule. Infinity always gets a parenthesis. Always. Why? Because infinity is not a real number. You will never actually reach infinity, so you can never include it. So we will never use brackets for infinity, but we always use parentheses for infinity. This includes both positive and negative infinity. Okay, if you haven't written this down yet, you should definitely write this down because this is actually a very important rule. Okay, now that we've covered the rules, let's do a few examples. Okay, what if I want all numbers between -2 and 5, but I don't want to include -2 and 5? Since -2 and 5 are not included, we would have open circles on both numbers. But now that we have the number line, how do I convert this to interval notation? Again, remember that we go from the smallest to the biggest. So what's the smallest number that we can have? So the smallest number that we can have is -2. And the biggest number that we can have is 5. But since it's an open circle on -2, we know that it's not included. So it's going to be a parenthesis. And since there's also an open circle on 5, we know that it's also not included. So it's going to have a parenthesis. Okay, what about this one? Pause this video and try to get the interval notation for this by yourself. Okay, so the smallest number, again, that we can have here is -2. And the biggest number that we can have here is 5. Now there is a closed circle on -2, which means it's going to have a bracket. And there's an open circle on 5, which means it's going to have a parenthesis. Is this what you got? Okay, so let's summarize interval notation. Remember, parenthesis means not included. And when you see an open circle on a number line, it also means not included. Brackets means included, and closed circle means included. Infinity, both positive and negative infinity, always gets parentheses. And when we're ordering our interval notation, we always go from smallest to largest. Now that we know interval notation, let's talk about inequalities, because domain restrictions are almost always written as inequalities first before we convert them to interval notation. What does this mean? So an inequality is just a statement that compares two values, x greater than 3. This means that x can be any number bigger than 3. X cannot equal to 3, but it must be bigger than 3. By the way, I know students sometimes get confused between greater than and less than. So just think about G, and where is the tail of this G pointing? It's pointing in this direction, so that's greater than. And then think of an L for less than. Where is the tail of this L pointing? So that's a less than. So that's just something quick to help you know the difference between greater than symbol and less than symbol. So back to this problem. We said x is greater than 3. So what are some values that x could be? X could be 4, x could be 5, could be 6, all the way to infinity, right? Could x be 3.1? Yes, because we said that x can be any number greater than 3. So as long as the number is not 3, but it's greater than 3, x could be that value. So how would we represent x greater than 3 on the number line? Does 3 get an open or a closed circle? Since 3 isn't included, it would be an open circle. Now the next question is, what direction should our line point? Should it go towards the left or should it go towards the right? What direction has the numbers that are greater than 3? The right has the numbers greater than 3, so we would point towards the right. But now, how would we put this in interval notation? Remember that when we're doing interval notation, we always go from the smallest to the biggest. What's the smallest value that x can have? 3. And what's the biggest value that x can have? Infinity. Remember that infinity always gets a parenthesis. And since this is an open circle, 3 is not included, it will also get a parenthesis. So now what changes? This is pronounced as x greater than or equal to 3. The equal to tells us that now 3 is included. So what are some possible numbers of x? Now x can actually equal 3 because we see this equal to, and it could equal 4, 5, 6, blah blah blah, all the way to infinity. How would we put this on the number line as well as in interval notation. Now 3 gets a closed circle and the arrow is still pointing towards the right direction. Now what would it look like in interval notation? Remember that for interval notation we go from smallest to biggest, so it's going to be 3 to infinity. But now 3 is going to get a bracket because it's included, and infinity, that is not going to change, is always going to have a parenthesis. Okay, let's look at another example. X is less than -1. What are some numbers that x could be? Since it's less than -1, x could be -2, could be -3, -4, blah blah blah, all the way to -infinity. Can x be equal to -1? No, because -1 is not included, right? There's not equal to underneath this less than, so -1 is not included. Since it's not included, it's going to get an open circle when we do it on the number line. So let's go ahead and do that on the number line. So there's going to be an open circle on -1, and then the direction that's less than -1 is towards the left, so we're going to point towards the left. And now let's go ahead and put this in interval notation. What's the smallest number that x can have? -infinity. And what's the biggest number that x can have? -1. Always infinity gets parentheses. -1 will also get a parenthesis because it's not included. And now this is what it looks like in interval notation. Let's look at our early example. We said this is what it was going to look like in interval notation, but what would it look like as an inequality? Now we know that -2 and 5 are not included, but all the numbers between -2 and 5 are included. So what are some possible values that x could be? X could be -1, could be 0, could be 1, could be 2, could be 3, could be 4, could be 4.99, but it can't be 5, and it can't be -2. Essentially, x can be any number between these two numbers. What does this mean as an inequality? Is x less than -2 or greater than -2? X is greater than -2. Is x less than 5 or greater than 5? X is less than 5. How would I combine these two into one inequality? I would write x in the middle and I'll put two inequalities next to it. Which number, and now we have to decide what number is going to go here and what number is going to go here. Which number is x less than? X is less than 5, so 5 would go here. Which number is x greater than? X is greater than -2, so -2 would go here. So this interval notation will look like this as an inequality. Let's look at the second example that we looked at earlier. How would we convert this interval notation to inequality? So again, what are some possible values that x can have? Now -2 is included, so x could be -2, could be -1, could be 0, could be 1, could be 2, could be 3, could be 4. But x cannot equal to 5. How would I put this in inequality? So x is less than or greater than -2. X is greater than -2. But remember that -2 is also included, so x is actually greater than or equal to -2. What about for 5? Is x less than 5 or greater than 5? X is less than 5. Now we're going to go ahead and combine these two. We write x and we put two inequalities on the side. Which number is x less than? X is less than 5, so 5 is going to go here. Which number is x greater than? X is greater than -2, so -2 is going to go here. But don't forget that it's also equal to -2, so we have to make sure to note that. So this is what this would look like as an inequality. So now let's pivot to talking about solving inequalities. The process of solving for inequalities is actually almost identical to solving equations with just one important difference. So let's go ahead and solve for x. The first thing that we're going to do is subtract 3 from both sides of the equation. So then 2x is going to be greater than 7 minus 3, which is 4. And then we're going to go ahead and divide both sides by 2. So my x is going to be greater than 2. So now let's go ahead and show this on the number line and then in interval notation. So this is negative infinity and this is infinity, and now we're going to put 2. Is it going to be an open or a closed circle on 2? Since it's not included, it's going to be an open circle on 2. And we're going to point right since that's the direction that's greater than 2. What about as interval notation? We're going to go smallest to biggest, which is 2 to infinity. 2 has an open circle, which means parentheses, and infinity always gets parentheses. Let's go ahead and solve for x. So we're going to subtract 1 from both sides of the equation. So negative 2x is greater than or equal to 5 minus 1, 4. And now we're going to go ahead and divide both sides by negative 2, which means that x is 4 divided by negative 2, negative 2. Now, something that's very important, which is the big difference between solving for x when it's equal to and solving for x when we're dealing with inequality, is that when we divide or multiply both sides by a negative number, then we have to flip the inequality. What do I mean by flip? If the inequality was a greater than, it becomes a less than. If the inequality was a less than, it becomes a greater than. Since I divided by a negative number, I have to flip my inequality, and so instead of greater than, I'm going to have less than. Don't forget to keep the equal to, because that is not going to change. The only thing that's changing is the equal, is the greater than or the less than. So now let's go ahead and put this on the number line. So it's going to be negative 2, and on negative 2 we're going to have a closed circle, and then the direction that's less than negative 2 is this direction. And if I was to put it in interval notation, we go smallest to biggest. So that's negative infinity to negative 2. Infinity always has parentheses, and now negative 2 is included, so it's going to have a bracket. Now we finally got into the reason why we learned all of that, which is finding the domain of functions that have restrictions. So there are actually two main cases you see in algebra where the function could have restrictions, which is square roots and fractions. So let's start with square roots. Before we go any further, go ahead and put in your calculator square root of negative 2. Do that on your calculator and tell me in the comments what your calculator gave you. Most of you probably got undefined or math error. Why is that? You cannot take the square root of a negative number, at least not in the real numbers. So whatever is inside the square root must be greater than or equal to 0. What is the domain of this function? Or rather, what are the valid inputs that will not cause this function to be undefined? To not have undefined, we need whatever is inside the square root to be greater than or equal to 0. So we take whatever is in our square root and we set it greater than or equal to 0. In this case, we have x minus 3 inside our square root, so I'm going to make it greater than or equal to 0, and then I'm going to go ahead and solve for x. To solve for x, we need to add 3 to both sides of the equation, so now x is greater than or equal to 3. And you can test that for yourself. If I put 3 in here, I'm going to have 3 minus 3, which is 0, and the square root of 0 is 0. But if I put any number that is not fitting this inequality, which could be negative 5, for example, negative 5 minus 3 is negative 8, and if you put the square root of negative 8 in your calculator, you would get a math error, and that would be an invalid domain. So the only domain that is valid for this function is going to be x greater than or equal to 3. Those are the only valid inputs, so that would be our domain. So then how do we put this in the number line and in interval notation? On the number line, we're going to have 3, but on 3, it's going to be a closed circle since it is included, and we're going to point towards the right since it's greater than 3. And then when I put this in interval notation, I'm going to go from smallest to biggest, which is 3 to infinity. 3 is included, so it's going to be a bracket, and infinity always gets parentheses. So this is the domain for this function. So now let's try this one. What's the domain? To find the domain, we have to take what is inside the square root and set it greater than or equal to 0. In this case, we have negative 2x plus 4 in the square root. So we're going to make it greater than or equal to 0 and solve for x. We're going to subtract negative 4 from both sides of the equation. So negative 2x is greater than or equal to negative 4. And then we're going to divide both sides by negative 2. So x is 2. And don't forget that when we divide or multiply both sides by a negative number, we have to flip the sign. So if this is greater than, now it's going to be less than or equal to 2. So now let's put this on the number line. And on 2, it's going to be included, which means we're going to have a closed circle. And since it's less than, it's going to go in the left direction. And then in interval notation, we go from smallest to biggest. So it's going to be negative infinity to 2. Infinity always gets a parenthesis, and 2 is included, so it's going to have a bracket. Now let's move on to fractions. Same thing. Go ahead and find 2 divided by 0 on your calculator and tell me in the comments what your calculator gave you. Most of you probably got undefined or math error. And why is that? You cannot divide by 0. So whatever is in the denominator cannot equal 0. So we need to find which values make the denominator 0 and exclude them. So the problem is with the denominator. As long as the x value doesn't make the denominator 0, then it's allowed in the domain since it's a valid input. So again, remember, we need to exclude whatever will make the denominator equal to 0. We need to exclude those values of x. So I'm going to go ahead and go to the denominator, and I'm going to make it not equal to 0. And then we're going to go ahead and solve for x. To do that, we're going to add 5 to both sides of my equation, which means x cannot equal to 5, because if we put x as 5, 5 minus 5 is 0, and we know we cannot divide by 0. So what does this mean? It means x can be any value but 0. If we draw this on the number line, it will look something like this. On 5, since we can't have 5, we're going to have an open circle. We can have any number between negative infinity and 5, and we can have any number after 5, so 5 to infinity. We just cannot have 5. If we were to put this in interval notation, I will have 2 intervals. I'll have the interval first from negative infinity to 5. Both of them are not included. And then I'm going to have another interval from 5 to infinity, and they are both not included. So in the situation where we have multiple intervals, we usually use a U to combine it. Now this U is just the union symbol, which means combined with or. So the U symbol again is just a union, which means that we're combining 2 separate intervals into one domain. Let's do another example. What's going to be the domain of this function? Again, we take whatever we have in our denominator and we set it not equal to 0. And so now we need to solve for x. So we're going to take each thing and solve for x separately for each of them. So we're going to do x plus 2 and also x minus 2, and we're going to solve for x. So for this one, if I solve for x, x is going to not equal negative 2. And for this one, x is going to not equal 2, which makes sense, right? Because if I put negative 2 here, this is going to be 0, and 0 times whatever is 0, and that's a problem in the denominator. Same thing here. If I have 2 here, 2 minus 2 is 0. 0 times anything is going to be 0, and that's also a problem in my denominator. So x can be every real number except negative 2 and 2. If I was to put this on my number line, it would look something like this. On negative 2, I'm going to have an open circle, and on 2, I'm going to have an open circle. Now, all the numbers between negative infinity and negative 2 are valid. All the numbers between 2 and infinity are valid, and all the numbers between -2 and 2 are valid. What would this look like in interval notation? So we're going to have 3 intervals. We're going to have the interval from -infinity to -2, and none of them are included, so I'm just going to use parentheses. I'm going to use the union symbol to combine them, and then I'm going to have from -2 to 2, also not included, so we're going to use parentheses combined with a union, and then 2 to infinity, they're also not included, so we're going to use parentheses. So this is what the interval notation is going to look like for this domain. Okay, let's summarize everything. Interval notation, remember that parentheses means not included. Also, open circle means not included. Bracket means included. Closed circle means included. Infinity, both positive and negative infinity, always gets parentheses because they're never included. And we always go from smallest to largest or from left to right. When we have greater than a, we go towards the right and a is not included. And when we have x greater than or equal to a, we still go towards the right, but now a is included. When we have x less than a, now we go towards the left and a is not included. And when x is less than or equal to a, we still go towards the left, but now a is included. The most important rule to remember for inequality is when you multiply or divide by a negative number, always remember to flip the inequality sign. For domain restrictions, square roots need the inside of the square root to be greater than or equal to 0, whereas for fractions, the denominator cannot equal to 0. So in the next video, we're going to be moving into exponent rules. This foundation is needed before you can understand exponential functions. So subscribe so you don't miss it, and I'll see you in the next one. Bye!